Discover the fundamental force that powers our modern world and unifies electricity and magnetism. Electromagnetism is one of the four fundamental forces of nature, governing how charged particles interact with each other and with magnetic fields. Let's start by understanding the two components, electricity and magnetism. Electricity involves electric fields and charges, shown here with vertical field lines. Magnetism involves magnetic fields and poles, shown with curved field lines. Electric charges, whether positive or negative, create electric fields around them that can exert forces on other charges. When electric charges move, they create magnetic fields, revealing the deep connection between electricity and magnetism. Let's explore how electric charges interact through electric fields. Opposite charges attract each other, with electric field lines flowing from positive to negative charges. Coulomb's law describes the electric force, F equals K times Q1 times Q2 divided by R squared, where K is Coulomb's constant. The force between charges is proportional to the product of their charges and inversely proportional to the square of the distance between them. Now let's understand magnetic fields and how they behave. A bar magnet has a north and south pole, with magnetic field lines flowing from north to south outside the magnet. Unlike electric charges which can exist alone, magnetic poles always come in north-south pairs. There are no isolated magnetic monopoles. Just like electric charges, magnetic poles repel each other, while opposite poles attract. The key insight is that electricity and magnetism are two sides of the same coin. When an electric charge moves, it creates a magnetic field, represented by these circular field lines, around the path of motion. The magnetic field from a moving charge is given by this equation, showing it depends on the charge's velocity and position. Electric currents in wires are simply moving charges, which is why wires carrying current produce magnetic fields around them. One of the most important discoveries is that changing magnetic fields create electric fields. When a magnet moves through a coil of wire, it creates a changing magnetic field that induces an electric current in the wire. Faraday's law states that the induced voltage equals the negative rate of change of magnetic flux through the coil. This electromagnetic induction is the principle behind electric generators that convert mechanical motion into electrical energy. James Clerk Maxwell unified electricity and magnetism into four elegant equations. Gauss's law for electricity: electric field divergence equals charge density divided by epsilon zero. Gauss's law for magnetism: magnetic field divergence equals zero, confirming no magnetic monopoles exist. Faraday's law: changing magnetic fields create electric fields. Ampere-Maxwell law: magnetic fields are created by currents and changing electric fields. Maxwell's equations predicted a remarkable phenomenon: electromagnetic waves. Electromagnetic waves consist of oscillating electric and magnetic fields perpendicular to each other, traveling through space at the speed of light. The speed of these waves equals 1 over the square root of mu0 times epsilon 0, which equals the speed of light. This led to the revolutionary realization that light itself is an electromagnetic wave. Electromagnetism is the foundation of modern technology. Electric motors use electromagnetic forces to convert electrical energy into mechanical motion. Generators work in reverse, using electromagnetic induction to convert mechanical motion into electrical energy. All wireless communication uses electromagnetic waves at different frequencies to transmit information. Medical imaging devices like MRI scanners use powerful magnetic fields and electromagnetic principles to see inside the body. Let's review the key concepts of electromagnetism. Electricity and magnetism are not separate phenomena, but two aspects of the unified electromagnetic force. Electric charges in motion create magnetic fields around them. Changing magnetic fields induce electric fields and currents. Light and all electromagnetic radiation are waves of oscillating electric and magnetic fields. From power generation to communications to computing, electromagnetism is the foundation of modern technological civilization.